We're going to practice continuity and derivatives. Okay, so this entire video all we're doing is practicing. So I made a mistake. We're going to tear this off. It's going to go right behind other on the same line as other, so you basically can't see that page. Then go ahead and tear this out, make it small so it can fit on both places, on both pages rather. Alright, so this is what your book should look like. So you see other, you can't see anything underneath that. For all real numbers, the function f of x, x squared minus 6x is blank blank blank. We need to understand two things from previous thing. In order to be differentiable, a function must be continuous, but just because it's continuous doesn't mean that it's differentiable. So we're going to take a look at this. So the first thing we're going to check for is it continuous? So I'm also going to teach you how to use a calculator. So you go y equals, and then you put in the equation. So x squared minus 6x. Then you go graph. But your window might not be right, so my window is not right. So x minimum is like the x minimum on the x-axis, so negative 10. Positive 10 is the max, going up by 1. Y minimum is negative 10. Y max is positive 10, going up by 1. Alright, so this is what it looks like. We already knew that. Is it continuous at all points? F of c exists everywhere. The limit as x goes to c exists, and they're always going to be equal. There's no discontinuity, so it's continuous. So let's take a look if it's differentiable. Well, are there any kinks? There are no points, vertical tangents, and it doesn't look like the other ones I know, so I'm going to go with yes, it is differentiable. Not only is it continuous, but it's differentiable because it's just a regular function. There's nothing special about it. So which option is that? A, differentiable and continuous. This is a listening check. Put a triangle around number 1. How about this absolute value function? So again, let's start off by drawing what it looks like. So this is the absolute value function, move 2 to the right. So let's check if it's continuous first. So I'm actually going to write the 3 things that make something continuous for the whole paper. So number 1, f of c exists. F of some number exists, whichever I'm looking for. The limit as x goes to c of f of x also exists. And the third thing is f of x is equal to the limit as x goes to c of f of x. We know this. So it exists everywhere, because even there, the limit from the left is equal to the limit from the right. And therefore, they're always going to be equal to whatever f of x is. So it is continuous. We know it's not differentiable because it has a kink or sharp point. I'm going to teach you how to put this in a calculator. So go y equals, and then we're going to write it in. To do that, you're going to hit math, and then it's not there, so go to number. So use the arrow to go to number, and then see it's the first one, absolute value. Press enter or hit 1. So absolute value of x minus 2, and then you go graph. And that's what it looks like, just like what we had. Perfect. Alright, so we know that it's not differentiable, so let's look for that. So yep, that's C. It's continuous for all real numbers, but it's not always differentiable because it has a sharp point. But it's differentiable everywhere else except that point right there. So it's differentiable everywhere else, but not at that point at 2. Alright, let's take a look at this other graph. Let's put it in. So y equals, and you can just hit clear to clear that. 2x raised, that little arrow thing up, I guess. Raise to 3 plus 5, then hit graph, and it graphs it for you. So the graph moved up, that makes sense because it's plus 5, and then we multiplied, we made it thinner. That's really what we're saying. But we can do this fractional transformation, but I want to use a calculator to teach you. So does it exist everywhere? Yes. Is it the limit exists everywhere? Yes, it does, and it's going to always equal. So it's continuous. Alright, so now we're looking at it's differentiable. Any vertical tangents? No, because this is not a vertical tangent, it's a slope. I don't know if you can see that. It's not directly straight up and down, and then it has a horizontal tangent. So this one is differentiable everywhere because there's no kinks, no vertical tangent. It doesn't look like the other graphs that we did before. So that's going to be option B, differentiable and continuous. Alright, so number 4. Let's go ahead and plug in the calculator so you can know what it looks like, even though we can do it by hand. Negative 1 over x. Graph it. So this is what it looks like. And we can zoom in. If you hit zoom and then go to zoom in, press enter, it zooms in. Then you hit zoom, zoom out, press enter, it zooms back out. Alright, so it looks like this. Alright, so is it differentiable? That's what we're looking at. So at x equals 0, it isn't defined, so it makes no sense to ask if it's differentiable. This is a listening check. Put a square around number 5. Put a square around number 5. So we know that x can't be 0. So It's not going to be A because that's all real numbers. And x can't be equal to 0. C and D has the arrow underneath, which means equal. So the only option is B. Alright, we have another function. So let's go ahead and graph it. Y, plot again, then just plug in the function. And this is what it looks like. Oh, look at that, it's a cusp. And that's what it's called, a cusp. Alright, we already know it's not differentiable there. That sharp point is not differentiable. So let's look for that. But it is continuous everywhere because the limit from the left equals the limit of the right. Everything is defined and it's going to be equal. So it's continuous but not differentiable. So that's going to be option B. Continuous for all real numbers but not always differentiable. I did look through the rest of them. Sometimes differentiable but not continuous. Nowhere differentiable or continuous. The rest of them don't make any sense. Alright, next one. Go ahead and plot it. Y equals cosine of 1 over x. Close the parentheses so it does the whole thing. Alright, so it does a little something. Zoom in, let's see what it does. So zoom in, press enter. Oh, so that's that function I was looking at earlier. Alright, that one. So that was cosine 1 over x. Alright, so the limit as x goes to 0, we can't really tell what's happening as it gets closer to 0. So it's not continuous because it's not approaching anything. So f of x exists. Well, it doesn't exist because cosine of 1 over 0 doesn't exist. So it's not continuous. And if it's not continuous, I know for sure it's not differentiable because in order for it to be differentiable, it must be continuous. As we head towards x equals 0, the function moves up and down faster and faster. So we cannot find the value that it is quote unquote heading towards, so it's not differentiable. This is a listening check. Put a star by the number 7. Put a star by the number 7. Alright, so it's going to be A, not differentiable or continuous at the origin because we don't know what the limit is there. It's not approaching anything. Alright. Next question. So we know what this one is. We're just going to move it what, to the right 3? Yeah. So there isn't a graph less than x equals 3. So there's no point of asking about whether it's differentiable there. It doesn't exist there, right? So no graph before x equals 3. So it makes no sense to ask if it's differentiable there. This is a listening check. Draw a smiley face at the end of this sentence. Draw a smiley face at the end of this sentence. The graph starts at 3, so we're going to check what happens at 3, okay, because it does have some equal to 3 questions here. So we're going to look at what happens at 3. So using the definition, and again, I could have actually done the shortcut on this, but anyway, I decided to use the definition we did earlier. So using the definition, we're going to just plug it in. F of x is the radical of x minus 3. F of c is 3. So f of 3 is square root of 0, which is also 0. So we're going to have radical x minus 3 minus 0 all over x minus 3 because that's what c is. Alright, let's simplify this a little bit. That's what we have. And then I'm going to raise it to the powers because I can simplify the powers. 1/2 minus 1 is negative 1/2. So it's really on the bottom. So it's going to be 1 over radical x minus 3. Alright, then plug in 3 in. I'm going to get 3 minus 3 on the bottom, which is 0. So 1 over square root of 0, which does not exist. Therefore, the derivative at 3 does not exist. So the only option it could really be is D. The domain is, the derivative exists for everything bigger than 3. But in the next one, okay, for this you have to make sure that your calculator is in radian mode. So I'm going to actually show you how to put it in radian mode if it isn't. So it should look like this, but if it doesn't look like this, it's because your calculator is not in radian mode. Hit mode, go down to radian, press enter. I'll put it in degree because you see if it's in degree, it looks like that. It's so weird. So all you have to do is hit mode, and then go to radian. So scroll down to radian, press enter, use the arrows, press enter. It has to be in radian mode, so it looks like this. Alright, so graphing it out, I do the isotopes first so that I can know how to graph it. They have to be perfect. Alright, and those values are negative pi, negative 2 pi, and then that's pi, and that's 2 pi. And you should know what these graphs look like. Alright, the function is not defined for values of x that are integer multiples of pi. So it makes no sense to ask if it's differentiable there. The function is not defined for values of x that are integer multiples of pi, so it makes no sense to ask if it's differentiable there. Because at pi, 2 pi, 3 pi, they're isotopes. This is a listening check. Write your name at the end of this paragraph. Write your name at the end of this paragraph. And so let's look at the options that we're given. No, because it includes pi. Because it's saying from 0 to 2 pi, so it includes pi. So no, that one's not true. It could be B, because it's saying from 0 to pi, and from 0 to pi there's a graph everywhere. It's not C, because it's saying negative pi over 2 to pi over 2. That means it includes 0, which is also a vertical isotope. So no, because it includes 0. And then the domain of the last one is all real numbers, and that's not true. So it has to be B. Alright, last question. Alright, even without graphing this, we could do this without graphing. Is it differentiable? Well, let's figure out if it's continuous first. So we know the bottom cannot be equal to 0. So that factors out to that, so x cannot be equal to plus or minus 2. So that's not defined, so it makes no sense to ask if it's differentiable there. Right, so f of 2 or f of negative 2 doesn't exist, so it makes no sense to even ask if it's differentiable. In other words, if it's not continuous, it's not differentiable. Alright, so the domain could be the first one. The second one isn't, because it includes negative 2 and positive 2. It's definitely not all real numbers. And the last one also includes negative 2 and 2. Alright, so we're going to graph it so we can look at it. And so that's what it looks like. You can use the trace button to trace like where it goes and so forth. So just hit trace and use the arrows to trace around. So it goes through negative 2 and 2. And that's pretty much it. Let's practice.